Hello, good evening, my dear friends and my respected teachers. My name is Mohammad Shahbaz Akhtar. I am doing my PhD from IIT Patna. My topic of presentation for the conference is heuristic-based cost-efficient serial frontal deployment over TWDM pound. I am doing PhD under the supervision of Dr. Anikadya and Dr. Sudhan Manji as my co-supervisor. Okay. These are my presentation outline. First we go through the introduction, then motivation, then the proposed architecture, objective, problem statement, proposed heuristic algorithm, simulation setup, the cost value which I have taken, numerical analysis, conclusion and future work, then the final references. Okay. In the current scenario, service providers are striving hard to overcome the challenge of being competitive in offering network that can efficiently provide gigabit of wireless connection. In the access network, every day we can see that due to new applications, the traffic rate in the access network is increasing day by day. So it is expected that the fifth generation mobile network is expected to offer a link rate of 1 Gbps per user with mobility and 10 Gbps without mobility. So to support such a tremendous growth of data rate, we need to redesign our entire access network so in a cost efficient way, so that we can cope up with the problem which are going to arise in future. At present, network providers use DRAN, distributed radio access network, to provide mobile connectivity to end user. In DRAN, in a base station, we have both digital units and the radio units. But in CRAN, what we propose that we took it is a new cloud-based paradigm acknowledged as one of the promising RAN technology for emerging 5G networks. What we do in CRAN, we take the processing unit, baseband unit from the cell site and move it to centralized location, and we only put the remote radio head radio unit at the cell site, which consumes very low energy. Also, when we put all the baseband unit to a centralized location, the operational cost will be reduced drastically, and the maintenance will be easier. Also, the site rent will reduce. So overall, using CRAN, we can reduce our operational and maintenance cost at very much. So what is front haul? As our topic also have the word front haul. What is front haul? When we took a baseband unit from the centralized location to a centralized location, the link between the centralized location, that is called BBU pool, to the remote radio head cell site, we provide a optical transport network to have the connectivity. This network is called front haul. Now, what is the motivation for doing this? Since when we use in DRAN, what is happening? Both the digital units and baseband unit, radio unit are at the same location. So we require a very short range of front haul. So in a mobile network, we use CPRIS, common radio interface, for this purpose. So when we took baseband unit to a distance which is far greater than earlier one, what we have to do? We have to design the front haul in such a way that we can provide the same capacity, same scalability, and end-to-end latency is very important, because in a 5G network the latency should be very low, in the order of microsecond or millisecond. So we have to design the front haul architecture. So this architecture has drawn a tremendous attention from both the academician and as well as industries. Now the question arises, what type of transport network we should use? As we all know that fiber is the best technology nowadays, because it has tremendous benefit right now. So we will use fiber network. There are various versions of fiber network. Which one of these is passive optical network. Passive optical network is a fiber-based network which uses passive devices in the remote nodes in the optical distribution network that do not require any power consumption, power source. So operational cost is very efficient. So in this proposal, we try to use time division multiplex passive optical network for this front hauling. So it is our proposed architecture. We can see that all the radio units are placed at a distance from the central office, and in the central office we put the bunch of BBU pool, and this in the front hall we use the passive TWDM architecture to provide the connectivity. Now my purpose in this work is to design this front hall architecture in cost efficient way so that it is feasible to deploy by the network operator. So in the front hall, what we have the devices, we can see that in downstream direction we have AWG, arrayed waveguide grating. It is basically multiplexer and demultiplexer, wavelength multiplexer and demultiplexer. Then the distribution fiber which connects to a power splitter. AWG has a splitting ratio, something, suppose that 1:4 splitting ratio. That means it will connect with 4 power splitter, and all the splitter will have different wavelengths. So the work of power splitter is to distribute or to aggregate the traffic of the base station. So the base station will send the traffic to power multiple base station, or remote radio units will send the traffic to power station. Then the passive devices, all the passive devices then took this traffic through a particular wavelength towards the AWG. AWG will multiplex these traffic coming over different wavelengths and sent to the BBU pool. These slides describe the same what we have already described, that TWD is a fiber based PON technology. Optical network units is also called optical terminal unit, which is placed at the radio unit side. Arrayed waveguide grating AWG and passive devices are placed in the distribution network, and OLT, optical line terminals, are placed at the BBU site. These are all the components of a TWDM PON. So in the figure 5, we can see that we have 3 stages of multiplexing. First, the multiplexing is done at the power splitter itself. The multiple ONU send their traffic, and this is aggregated at the power splitter. Second, multiplexing is done at AWG site, that all the traffic of different power splitter is come through the different wavelength or different wavelength, and it is multiplexed. And third, multiplexing is done at BBU pool itself. At the BBU pool, we have different digital units provided. All the traffic coming over different wavelengths are demultiplexed and sent to the respective digital units. These all the things are described in this slide. So the objective. So as already we discussed, we are going to design a transport network for this CRN front haul designing. We suggest a heuristic based two-phase optimized, which I have named it as recursive clustering and cardinality reorganization algorithm. The purpose of our CCRA is to explore the optimal number and size of each ONU cluster. We select make the cluster of these radio units. Okay. After providing the clustering, we select the most suitable location for placing our passive devices over the distribution network, because the prominent cost for any network design is the fiber deployment cost. So our objective is to reduce the total length of deployed fiber and number of required passive devices in the optical distribution network. For this, we propose a novel clustering algorithm for doing this for this purpose. Now this is the problem statement. What we have as an input. We are provided with a location of BBU pool. That this will be the location of BBU pool. We have a different number of dispersed ONUs or radio units in the geographical plane. So we have provided the location of ONUs, radio units, and the pool. Now we have to design the front haul architecture, so that the overall deployment cost is reduced as much as possible. And after the solution, what is the solution of this algorithm? The solution will be the detailed required number of first stage and second stage remote nodes for AWG and passive device placement. First stage is the stage for AWG, and second stage is stage for power splitter. Also, it will provide the complete interconnection detail of the which ONU is connected with which power splitter, which power splitter is connected with AWG, what is the splitting ratio of all these passive devices. All the detail we will get after the solution of this algorithm, as a solution of this algorithm. Okay, so one of the most traditional algorithm, clustering algorithm, which has been used in previous studies, K-means algorithm. But in K-means we have certain drawbacks. We can say drawbacks. That the first one is that approximation obtained can be arbitrarily poor with represent objective function, because K-means is in K-means every time when we run the program, we get a different set of final clusters. So we will not able to decide which is our best design, what is the optimal value of K, what is the optimal value of final cluster that can provide the least deployment cost. Second, it is hard to predict the optimal number of clusters. And third, sometimes it may happen that a cluster has certain number of ONUs that doesn't match with the standard splitting ratio available of the power splitter. Suppose that a power splitter has a split ratio of 1:8, and in a cluster there is a 9 ONU. So what will happen? For a single ONU, we need to increase the splitting ratio, or we have to put another power splitter. So what we do in this algorithm, that we reorganize the cardinality of the given cluster. So our CCRA solve all the issues which I have discussed. This is a flow chart. We cannot go into that detail to explain this flow chart, okay, because we have very limitation of time. So RCC is based on K-means plus cluster algorithm that addresses the first issue by defining better procedure to initialize the cluster centers. Second step is recursive ONU clustering, solve the issue of finding optimal cluster that guarantees the best design. And third, in the flowchart, we have cluster cardinality reorganization step that addresses the problem of exceeding number of ONUs remote in a group from a maximum available standard split ratio of a power splitter. These are the simulation setup. We use a Manhattan Street model. We use a MATLAB to generate these different network nodes. We took a square region of 20 km each side, where we put BB pool at the center, and all the ONUs are randomly, uniformly distributed over the square region. We consider 3 test cases where we vary the number of ONUs from radio units from 150 to 350 with a step size of 100. We also vary the number of ONUs that each OLT port of a TWDM PON can support, because it is a limitation of the device. So in this study, we assume that maximum 32 ONUs can be supported by each OLT port. These are the cost values which I have taken from a reference paper, which I have given at the last end of the slides. Fiber cable cost, labor cost for trenching and fiber laying, TWDM device OLT cost, which depends on the number of wavelengths it will support, power splitter cost, all the cost of the resources which we are using in the front hall, we have taken the cost. Even this cost may not be fully realistic, but when this cost is available to us, we can easily modify the component cost with the new cost. This is the first result. In the first result, we show the total front hall deployment cost for different number of ONUs for different approaches. For comparison purpose, we took 2 different clustering algorithm popularly used clustering. One is K-means clustering and another one is base station clustering algorithm, and we compare the results, and we can see that for in all the cases total cost for deployment is maximum for K-means algorithm followed by base station clustering algorithm. Then our proposal provides the least deployment cost for the same scenario, for same number of ONUs. It is because base station clustering algorithm is designed especially for clustering in network units. So it provides better result than K-means, and due to use of cardinality reorganization, we get better result than base station clustering. This is the result 2. Now in this case, what we do, we check the total deployment cost for different number of ONUs supported per OLT. Firstly, in the first case, we taken it to be 32. Now we change this value. Suppose that when number of ONUs per OLT is supported 8, 16. What will happen on the deployment cost? As we can see that when we reduce the number of ONUs, or radio unit supported per OLT, the deployment cost increases significantly. It is obvious because when the number of ONU increase per OLT port increases, the sharing of feeder fiber by ONUs also increase, leading to more cheaper deployment cost. However, the reduction in deployment cost is achieved on account of lower average bandwidth provided to each ONU because power splitter there is a sharing of bandwidth because as an input the input line of power splitter has particular wavelength that is shared among the ONUs. When the number of ONUs supported will increase, that means the number of ONUs sharing the common wavelength will increase, their average wavelength will automatically decrease. So it is the final result of our proposed scheme. Now in this we check the total cost, variation of total cost versus number of ONUs per wavelength. Earlier the result 2 was number of ONUs per OLT. Now when we increase the sharing of wavelength, wavelength per ONUs, we can see that when number of ONUs per wavelength increases, the total cost is decreases. We observe that the total deployment cost reduces on increasing the number of ONUs supported per wavelength. This is because as the number of ONUs supported by each wavelength increases, the required number of passive devices and OLT will also reduce. So we will successful in reducing the deployment passive device cost, network resources cost. Now this is the conclusion of our work. In this study we try to employ TWDM PON based network for CRM front-haul design. We suggest a heuristic algorithm named as recursive clustering quaternary organization algorithm. The simulation result shows that with respect to two different clustering algorithms, we are getting the least deployment cost. We also observed that on increasing the number of ONUs per OLT port supported, the total cost declines significantly. We also observed that the total cost deployment reduces on increasing the number of ONUs sharing a common wavelength, sharing supported by per wavelength. In future, we plan to extend the proposed algorithm to design cost-efficient front-haul over WDM PON, because WDM PON is a expensive technology, so we need but it has various benefits over TWDM PON. So this is our future plan. These are the references. Thank you.